So in the future, we're all experiencing this big data, this AI revolution. It's actually coming to the world of molecules. We're in the middle of it right now. We will, in fact, in the future, have interfaces that allow scientists to ultimately interact with a machine learning or algorithm, as you've just witnessed with ChatGPT. But you'll be able to actually ultimately be able to think through molecular design, thinking through that in the context of an AI, an engine that interfaces with the reality of nature, but then also human consciousness. And I think we're in this really critical moment to where the data is actually finally being generated, the machine learning is actually being established, and the future is really exciting because we're going to design molecules as we need them to actually not only impact human health, but to impact everything else that we experience here on Earth. So a big part of my group in the future is to establish big data, systems that generate all this important data at the molecular level so that we can fundamentally really train efficient algorithms that can then actually spearhead this notion, this need to make what we call artificial molecules that actually have the desired functions that we actually desire. And this might seem like a dream, but we've actually already started doing this. We're the first people in the world to actually use machine learning to design abiotic, so things that aren't designed by nature, mini proteins. And we designed them so that they could effectively deliver antisense oligonucleotides into cells. And it turns out it works so well, we have more putative mini proteins than we can possibly ever study. They work phenomenal. They teach us about how structure-activity relationships actually drive uptake and delivery. We're able to translate these findings into animal experiments. And so that is providing us with ammunition to say, yes, we need robots, we need machines, we need to automate chemistry, we need to automate the science so that we can learn as much as we possibly can using machine learning. And the hope here is that we can leapfrog into this new space of innovation. And that's really what's driving me, and that's what we're trying to build here. We're doing this actually with Professor Manolis and CSAIL here at MIT. He's been a leader in GWAS, trying to understand how genome level changes actually are causal drivers of disease. And so we're looking at this entire map and we're building knowledge trees to really understand what is it that's driving, for instance, obesity. And then we're going to come over into my laboratory and understand how do we rapidly make these molecules and test them based on these hypotheses. And the last big bit of this is that we're working with Marinka at Harvard Medical School, who's a leader in building what's called the Therapeutic Data Commons, which is bringing in all of the information that we have available to build machine learning models. And before we do experiments, we can ask questions about how does this molecule or design actually distribute within a human, for instance. And so we're converging here to build a whole new paradigm of thinking through AI-driven design of molecules to interact with humans.